GPX glass processors are capable of making a variety of optical fiber components to serve a wide variety of scientific industries, such as medical device manufacture, astronomy, spectroscopy, telecommunications, fiber laser manufacture, and sensing. GPX series glass processors were designed to develop and execute precise and repeatable recipes for glass processing applications. Tapering is an important step in the production of many fiber components. The two most common methods for tapering are biconic tapering and draw tapering. For a biconic taper, heat is applied to the fiber and both ends are pulled. This is especially useful for making fused fiber couplers, wavelength division multiplexers, or submicron diameter tapers. In a draw taper, heat is applied to the fiber, and one side pulls or draws the taper, while the other side feeds material into the furnace. This is especially useful for achieving precise geometric control of the taper shape for mode field adapters and power combiners. In this video, we will show how to set up the taper parameters and demonstrate how a GPX glass processing unit can be used to produce that taper using the draw technique. The taper properties can be accessed through the Splice menu. On the Taper Dimensions tab, the user can set the initial fiber diameter, desired waist diameter, and the length of the down taper, waist, and up taper portions. The taper parameters outline the behavior of the GPX during the process. For instance, whether the taper is drawn by the fiber holding blocks moving to the left or right, or whether the filament starting power remains constant as the taper is drawn, or reduces as the glass becomes thinner. Further control of the taper profile can be achieved using the Custom Taper Profile tool. The user simply defines the taper geometry, and then the software determines what fiber holding block motor movement is required to achieve this. The Taper Load Positions tab defines where the fiber holding blocks should be at the start of the taper. The Load Taper process moves the fiber holding blocks to the taper start positions while compensating for motor backlash in the taper draw direction. In this video, we will taper a 400 micron diameter double-clad fiber down to 250 microns, which is common for mode field adaptation of pump lasers. Tapering a fiber can be completed in 4 steps. First, the filament is normalized. Then, the fiber is prepared for tapering. Then, the GPX executes the taper. And finally, the GPX can be used to measure the waist diameter and allow the user to tune the parameters. As with other glass processing applications, to assure that a consistent and repeatable amount of heat is delivered to the fiber, it is important that the filament is normalized regularly. When normalizing before a taper process, the bottom inserts must be locked into the fiber holding blocks, even if they are transfer inserts. This locking ensures the alignment of the fiber across the left and right fiber holding blocks is maintained, even when normalization fibers are unloaded and the taper fiber is loaded. For more detail on normalization, see the dedicated video in the notes. If the normalization does not converge, simply unlock the bottom inserts to prepare 2 new fibers. Lock them in the fiber holding blocks and normalize again. When the normalization converges, open the lids of the fiber holding blocks and the transfer inserts to remove the fibers. After the normalization is complete, the next step is to prepare the fiber which will be tapered. Unspool a length of fiber. Then, mark the section of fiber to be stripped. Use an appropriate strip tool to window strip the fiber coating. For larger diameter fibers, it may be easier to use a razor blade. Thoroughly clean the fiber using a wipe soaked in solvent such as acetone or IPA. Now that the fiber has been prepared, the GPX can be used to draw the taper. The routine will begin by sending motors to the correct start positions and taking a baseline reading of the tension. Next, the routine will pause, so the fiber can be loaded across both fiber holding blocks. The lids should be closed left to right. Then, a known tension will be applied across the fiber, and the Taper Mark II process will initiate. As the filament turns on, the fiber holding blocks start to move in the taper direction. The glass processor controls their speeds and relative movement to form the geometry of the down taper, waist, and up taper. When the process has completed, the filament and splice head will return home. Finally, the taper waist can be measured. While the measurement guides can be used to verify the size of the taper's waist, the full length of the taper is often too long to be viewed on screen. The fiber holding blocks can be moved synchronously to view different parts of the taper. For a more complete image of the taper, the process Taper Measurement can be used. This will automatically move the whole taper under the lens, collecting a series of images as it goes. The images are then stitched together so that the full taper profile is displayed. Not only does this process provide the taper profile across the length of the taper, but the image also contains information about how the filament power and measured tension changed as each section of taper was drawn. This diagnostic information can be used to further refine the taper parameters or monitor quality in a production environment. Now that the taper has been drawn, this fiber might be cleaved at the waist and spliced into a fiber laser, or it might be retensioned in order to verify optical performance before additional processing steps, or integration into another device. If you have any questions or concerns, please email us at techsupport@thorlabs.com or vitran.uk@thorlabs.com.